You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back to Vocal Technologist. It's Wednesday, so we're diving into the InfoSec side of things. You know, while Web3 gets a lot of attention for decentralization, the basic security challenges across all tech, they're just as critical, maybe even more so.
Absolutely. And what we're looking at today really highlights how fast these threats are changing, from AI infrastructure right down to the apps you use every day.
Yeah, understanding these shifts is key, right?
Yeah.
Especially in Web3, but really everywhere online.
Exactly. It's vital.
So let's kick off with something pretty startling, actually. It's called ONEFLIP, a Rowhammer-based attack.
Rowhammer.
Yeah.
Exploiting physical DRAM flaws.
Right. And this ONEFLIP thing, it can apparently insert backdoors into AI models just by flipping a single bit in memory while the AI is working. Think about like a self-driving car suddenly seeing a stop sign as, I don't know, a speed limit sign. The potential impact is just, wow.
It is alarming, definitely. But it's important to note the conditions needed here. You need white box access to the model so you know exactly how it works inside, and you need to be on the same machine.
Okay, so co-location.
Yeah, with specific memory types, DDR3 or DDR4. So it's not a simple remote attack. It points more towards maybe multi-tenant cloud setups or dedicated AI servers being the main worry.
Gotcha. Still pretty insidious, moving from software bugs to actual hardware manipulation.
Yeah.
But AI faces other threats too, right? Like prompt injection.
Oh, absolutely. Indirect prompt injection is a big one. We've seen it with things like Perplexity Comet.
How does that work exactly?
Well, attackers basically hide malicious instructions inside, say, a web page the AI is looking at. The AI assistant then gets hijacked because it can't easily tell the difference between your instruction and the hidden one.
And then it could steal data, like OTPs, banking info, things like that.
Potentially, yes.
Yeah.
Across your authenticated sessions. It's quite clever, really.
So how do you defend against that? I mean, telling an AI what's trusted versus untrusted content seems tricky.
It is tricky. Defenses involve things like architecturally separating user commands from web content, maybe requiring explicit user OKs for sensitive actions, and isolating these agentic browsing sessions where the AI goes off exploring the web.
Okay, isolating the AI's web surfing. Makes sense.
Yeah.
So moving from AI itself, what about the people building the software? Developers seem to be a target too.
Definitely. We're seeing attackers get really creative with hiding malicious code, especially in Python. They're trying to obscure dangerous functions like exec and eval.
How are they hiding them?
Various ways. Using homoglyphs characters that look the same but aren't using built-in modules in weird ways, variable tricks, base 64 encoding, lots of layers.
So even if you have tools scanning the code.
Right. Static analysis tools help. They can flag suspicious stuff, but honestly, often you still need that human review, someone who can look at complex obfuscation and figure out the real intent. It's often a mix of automated and manual effort.
Human insight's still crucial. Okay, let's zoom out a bit then to cloud infrastructure. AWS had a bit of a logging issue recently.
Yeah, Datadog found something interesting, though AWS has patched it now. Basically, an API call in AWS Resource Explorer, list resources, wasn't being logged by CloudTrail by default.
Why not?
It was classified as a data event, which often aren't logged automatically to save on volume. The problem is, enumerating resources can be a key step for an attacker planning their next move.
So a potential blind spot for security teams.
Exactly. AWS reclassified it as a management event, which is logged by default. But it really shows how these subtle configurations in big cloud platforms can have, pretty significant security implications. You need to know what's being logged and what isn't.
Good reminder. And looking even broader, Google's taking steps with Android apps in certain regions.
In Brazil, Indonesia, Singapore, Thailand. By late 2026, developers there will need to verify their identities.
What's the goal there? Just blocking malware?
It's partly that, but it's also about building trust. Fighting App Store supply chain attacks, which can be more common in some areas. It's about verifying the developer, not just the app's code.
Right, adding another layer of trust. Okay, one last area, and it's a bit sobering. Federal court cybersecurity. Senator Wyden raised some serious concerns.
Yeah, that report was quite something. Allegations of critical systems unpatched for 5 years.
5 years, wow. Leading to hacks? Stolen data?
Allegedly, yes, including sealed case data stolen by Russian hackers, and also really slow adoption of things like phishing-resistant multi-factor authentication.
It just underlines that even critical infrastructure isn't immune to basic security failures.
It really does. It shows how vital robust security practices and, importantly, oversight are. Doesn't matter if you're cutting-edge AI or a decades-old institution, the fundamentals apply everywhere.
So it really seems, whether it's AI, cloud, developers, or federal systems, that constant vigilance and understanding these evolving threats is just non-negotiable for anyone online today. Staying informed helps us all build a more secure digital world, particularly as Web3 adds its own complexities.
Couldn't agree more. And maybe that brings us to a final thought for everyone listening. Considering all this, what security assumption, maybe one you take for granted, might you reevaluate in your own work or digital life today?
Spoken Tech for your ears.